No.
Okay, this is the first part of 6.5 today. Begins on page 362 if you want to get there and stay with us. The title of this is called Logistic Growth. If there's a particular skill that you got to have, you're not going to be able to do most of these. So it's kind of an algebra skill, but we never teach it. If we teach it at all, we never teach it until pre-calculus. And I don't ever get to it because ISU and the pre-calc that I teach takes up too much of my time, and I don't get to teach you there. So I have to teach you here. Because it is necessary skill, but it's something you can learn in a day, so it's not that big a deal to let me wait on that. And it's not that useful of a skill unless you go on to calculus, so I don't mind not teaching it pre-calc. You know what I mean? Okay. But there is some more practice if you would like it, and I don't know how many you want to do that, but there's more practice in the pre-calc book, and how long you want if you want to practice on this more than you're going to get here. I don't think you will, because when you see it, it's new and strange and kind of weird, but it's completely accessible by you. You can handle it. It's called partial fraction decomposition. And this is the idea behind partial fraction decomposition. Usually, not usually, almost exclusively in your life, probably exclusively, when they've asked you to add two fractions together, done something like this. I'm just going to stick with the numbers so you don't have to focus too hard on the algebra yet. If we want to add those two fractions together, what do you got to do? Which is?
35.
Okay, so we would put the 35 over here. That's what they both have. And then we would go back and this one by 5 over 5. And this one by, I'm going to put it here a little tiny. We know what we're going to do. And then what?
You put the numerators up there.
Yeah, so we'll get this times this is 25 over 35, but I've already put it over 35 by chunking them together here. And then 14, like that, and the result is 39/35. If you had to do that by hand, that's what you would do. Nobody does arithmetic with fractions by hand because you got those powerful tools on your desk. But this is the process, and this is the basic idea, right? Yeah. Partial fraction decomposition takes this and recovers this. There may be multiple ways, but not with an algebraic one. You'll see in just a minute. So what we would say is, if we gave us this and they'd say, okay, well that means what we would do is factor this 5 times 7. Factor that, like, so if this were polynomial, we'd factor it, right? And then we realized that this came about by having something over 5 added to something over 7. The objective is to recover the somethings. And the process, just so you can see, if we do quite a lot of bit of thinking here, maybe not too much, especially since we know where it came from, we can recover these. But right now we have an equation with 2 variables in it. The objective, when it's algebra, and you'll see why the algebra thing works better than this in just a minute, but the idea is to recover A and B by solving this equation by either rewriting A in terms of B or B in terms of A, or doing a really slick thing called having one of them keeping one of them out while we work on the other, and then making this one go out while we work on this one. You'll see. But the objective is, when you get to this stage right here, when you've taken the whole thing and split it up into these by factoring, then what you do is you multiply through by the common denominator, and you end up with this. 39 equals 7a plus 5b. Do you understand that? Yeah. Canceling as you go through. This cancels here entirely, leaving you 39. That leaving you a 7 times a. 7 cancels that out, leaving you a 5 times b. Now this still has 2 variables in it, and you're not supposed to be able to solve an equation that has 2 variables in it, but we realize that a and b are very likely not fractions. And that cuts down on the things that we can do. 7 times what? 5 times something else would give me 39. You start thinking about those things, and there's not that much. You start putting things in there. That's not the objective. There is a way when these are written, polynomials are written, there's a way to get this one to disappear for a minute while we work on this one, and then let this one go to 0 while we work on this one. That is not quite available to us right here. You'll see. But that's the idea. take an added together fraction that's in this form and recover the 2 things or 3 things or 10 things that added together to get that. We're not gonna do more than 3. We'll have to do one problem that's got 3 in it. For the most part, it's usually just 2. Okay, so let's try it on an actual algebraic problem. Like example 1, we have, can somebody read that to me?
Right.
Wait, I'm ready.
Okay.
All right.
Write the function f of x equals x minus 13 over 2x squared minus 7x plus 3.
Okay, now I erased it so that I could stay online here on this one board. But do you remember what we did when we went to split it up? We factored the denominator. Can you do that? Without looking at the book? Don't look at the book.
2x.
We're going to have a 2x and an x, right? And happily, that's also prime, so it's got to be 3 and 1 or 1 and 3 if it's going to factor, and it does. Can you see that I want the 3 here so I can get a 6? And then add 1 more to get a 7, they're both negative? Okay. If you'll recall what we did with the numbers then, that means that once we got that factor, that means that this is equal to some number over 2x minus 1 plus some other number over x minus 3. You follow?
Yeah.
Okay. Then the next thing we did is get all our denominators to divide out by multiplying through by the common one, which is these 2 things. Do I have to write them up there? I will. Okay. We're going to multiply through by 2x minus 1 and x minus 3. That's what we're multiplying every term in our new equation with. They both cancel here and leaves me with x minus 13. Over here, I have a times x minus 3 left. And here, b times 2x minus 1 left. That flattens it out. I'll have to deal with fractions. You good with that?
Yeah.
Okay, now here comes the trick that wasn't available to us when we were dealing with just numbers. Over here on the side, I'm going to, and you can write this down too. Yeah, I don't know. I'm going to say let x equal 3. Why would I choose that? So this term can get out of my way for a minute. You see how that'll happen? So right now, I'm going to let x equal 3. Can I do that? Yeah, if I let x equal 3 up here, I've got division by 0, but I don't have those denominators anymore. So letting it equal 3 will just get this out of the way for a minute. And that means I'm going to have a negative 10 equals b times 5. You see that? You do all that in your head?
Yeah.
I'm letting x equal 3. If I let x equal 3, this is negative 10. This goes to 0. This is 6 minus 1 or 5. I'm letting x equal 3. Make that substitution in all places that it occurs, and one of these will disappear where you can focus on just b. Gives you negative 2 equals b. So now I know what b is. I'm going to circle that up. I'm going to use
When is that just when x is 3, or is that all the time?
it. That's all the time.
This is crazy.
How
It
is
is. It is kind of crazy.
So if we let x be anything besides 3, would b still come out as negative 2?
No, but we'd have an a to deal with as well. The objective by letting x equal 3 is to get a out of the way for a minute, so that we have an equation written only in b and solve.
So yes, except we couldn't figure that out. It would equal that, we just couldn't figure it out.
Right.
It's just like the one.
What do you want to let x equal next?
1/2.
We're just finding the
Yes.
one place where we can find it out.
Okay. If I let x equal 1/2 in this right here, what will this be?
Negative 12.5.
Yeah, negative 12.5. We can go ahead and go with that. This one will be
A times negative 2.58.
Do you agree with that, everyone? And that one goes to 0 because we strategically let x equal something to lock that out. What's negative 12.5 divided by 2.5?
5.
So what we have discovered then is that this fraction came from adding together 5 over 2x minus 1 plus or minus 2 over x minus 3.
Wait. How do you compute that?
Well, we can add them together and I'll show you. Well, because I know what a and b are. So I know that this side a is 5 and b is negative 2. So this fraction is equal to the difference of those two fractions. because I now know A and B.
So how can this be helpful?
I'll explain in just a minute. But it is a skill you need. I just want to establish the skill in your mind, and then you'll see why it's extremely useful in a narrow set of circumstances. But boy, when you hit that, it sure is a happy thing to have, a happy skill to have.
Oh, so when you multiply them out by
No,
one,
when you add those together using common denominators, you'll get that back.
really?
Do you want me to prove it to you?
Sure. I mean.
What's the common denominator here? Since they're both linear, the common denominator is 2x minus 1 and x minus 3. So I need to multiply this one by,
X minus 2 over X minus 2.
no, x minus 3 over x minus 3, and this one over, or 2x minus 1 over 2x minus 1, right?
Wow.
That's going to be 5x minus 15 minus 4x plus 2, which is,
X minus 13. Oh my gosh.
pretty cool, huh?
Where has this been all my life?
Well, I'm not sure you needed it until now.
It's still cool.
It is. To be able to pull something together, be able to pull it back into the two things that added to make it, that's pretty clever.
What's the,
You probably did if you had Mr.
how do you
Porter.
write the line?
He has the time to do it. I don't. I have other crap I gotta get in.
There's
Yeah, you've seen
five.
this.
This is similar to
This is so
the one way
familiar.
you write the line. Just remember, like AX plus BY equals C or something.
You're thinking about completing the square. I don't think they're anything alike.
No, it's like an algebra one or pre-algebra.
Okay, you think about it. You think about it and let me know. Because it could be like something like that, but I'm not seeing it right now and I gotta move on. Okay, all right. Okay, so you followed through on that one?
Yeah.
Here's why it's useful, folks, in calculus. Do you remember, does anybody remember anything that I have, well, this is gonna be a hard thing. Think back, not a couple of days or so. Can you think back on anything that some of you have tried to do and I said, you can't do that unless,
A line.
Unless it's linear.
unless what's linear?
Function.
The function you're trying to antiderive, its denominator has to be linear in order to integrate it
Oh, so
with a logarithm.
we can make our fractions linear and then.
Yeah, this is quadratic. Logarithm is unavailable to us in this form.
So we
But
make
it's
it.
quite available to us here. If we decompose it into this, then I can integrate these separately and use a logarithm. That's why it's useful.
Is that why you emphasized it so much? Probably.
No, because people make that mistake all the time. They think, oh, I got a denominator, I'll just log it. No. You can only antiderive a fraction if its denominator is linear and its numerator is constant. Okay, so that's why this skill is extremely useful. So I'm going to erase this. We're going to try another one, and this next one's going to be rather daunting. You know what daunting means?
Like scary.
Yeah, it's something you got to get done, and it looks like it's going to be rough. But here we go.
I was watching game breaking and there's a ship called Dauntless.
Yeah, the Dauntless means you can't scare me.
Isn't that the fast?
That's the interceptor. Dauntless.
watched.
Not all of it. Not all of it.
Okay, so we're actually going to apply this to integration. We're gonna make this work for us so that we can get an integral done now. Rather than just practice the little skill, we're going to actually do it. So it's what we want to integrate is 3x to the 4th plus 1 over x squared minus 1. 3x to the 4th plus 1 over x squared minus 1. We wish to integrate that. And it's an indefinite integral, so we're focused on the integrating skill, not finding an area under a curve or anything. So what do you suppose the first step is?
Factor.
Separate them.
No, that is not the first step.
Oh.
Here's the problem. Remember what I just said, and it was very subtle, and it went right by some of you. I was looking at Mariah. She nodded her head. She's the only one. But some of the rest of you may have caught it. I said you cannot use a logarithm unless the denominator is linear and the numerator is constant. Is the numerator constant? We have to, folks. Listen,
Factor something
you're not gonna like this.
Divide it.
Shh, we have to divide it. We have to do long division first. Why do we have to do long division first? Because this supersedes this. We've got to get it whittled down so that the fraction on top has a smaller degree than the one on the bottom.
And it has to be constant.
Can we even make that happen?
when you actually do the integral using logarithms, yes, but we'll get there. Do you remember that A and B were constant before?
Yeah.
Okay, we'll get there, but
In order to answer you right, it can't be linear, A and B can't be linear.
A and B cannot have an X in it.
Okay, good.
Yeah. All right. So we've got to deal with this first, so that we're dealing with, when we actually do the decomposition, the numerator's degree is less than the denominator's. So we have to do long division first. So it's going to be x squared, and if you really want to keep track of everything, it'll be x squared plus 0x minus 1. I got a feeling you guys won't need this because you're pretty sharp.
Oh, this
On the top, if I'm keeping track of everything, that's going to be 3x to the 4th plus 0x cubed plus 0x squared plus 0x plus 1. Remember these little details of long division? Okay, here we go. What we do is we focus on this first one and this first one first. 3x squared, good.
Are you gonna,
3x squared, what?
Is that hurts my brain mistake.
you write it over the X squared.
Okay, fine.
If you're gonna go and write out all the zeros, we gotta use them.
All right, fine. Fine.
Now you multiply it.
Now you take this, times all of those, and you get 3x to the 4th and 0x squared cubed and negative 3x squared. And we change the signs and add. Changing the sign on that doesn't do anything. This adds out, this adds out, this adds up to 3x squared. I'm going to bring down the 0x and the 1 because I want to divide this quadratic into this quadratic, and I can bring the constant down as well. Okay, you get x squared into 3x squared is plus 3, and then we multiply, we get 3x squared plus 0x minus 3 minus 3. Change the signs and add. These are out. This adds up to 4. So here's what we've got. That thing that we wanted to integrate is now this integral. 3x squared plus 3 plus 4 over x squared minus 1. That's what we're going to decompose.
Oh no.
Yes, sir.
Forgot all about it.
Okay, so now we're only going to use
Now we
that
can
part,
integrate it separately.
the part, the fraction decomposition, only on the 4 over x
Only
squared.
on the remainder. Because these are highly accessible, integrable things. So we're going to decompose that next. So we can get all the pieces of the integral, and then we will integrate. Does that sound good?
Yeah.
So this I'm going to decompose, and that's going to be 4 over x squared. Can I write it as x plus 1, x minus 1? Factor it as I write it. Equals a over x plus 1, b over x minus 1. Next.
Yeah.
Multiply through by the common denominator. 4 equals a x minus 1 plus b x plus 1. Y'all able to handle that? Then we let, what do you want to let x equal? 1. Then I have 4 equals 2b. 2 is equal to b. Keep that in mind. Now we let, what's the next let? X equal negative 1, and we end up with 4 equals a times negative 1, right? No, negative 2. If we let x be negative 1. And b's out. So a is negative 2. So now our integral becomes the integral of 3x squared. If you're right, if you're okay, I'm going to do this. I'm going to go 3x squared. I'm going to start the integral process on the pieces I can. Plus, by the way, if we're being really true to things, they should be a dx. Plus 3 times the integral dx plus, no, minus 2 times the integral 1 over x plus 1 dx plus b was 2 times the integral 1 over x minus 1.
Well, that
dx.
sucks.
But everything is now integrable. Now that we busted it up into pieces, we can handle it because those guys still have denominators, but they're linear, which means logarithm is available to us. You with me?
Yeah.
Okay, now I'm really running out of space here. So this is what I want to integrate now that I've got it all busted up. What's this one's integral?
1/3 x squared. X cubed, X cubed,
1/3 X cubed.
X cubed.
It was really probably a little bit of a hindrance to take that 3 out in that case. It's, the 3's out there. I probably should have left it in there, would have been easier to see, but it's just x cubed. You with me? And then
3x
3x,
minus.
So which one is that one? Is that two
Let's
natural
do
log?
2 ln.
That wasn't like a sign or anything.
and well, you would have to account for it with the chain rule if there was a coefficient on x, but there isn't. Plus
2
ln.
log of
x minus 1.
plus c.
Oh,
Plus C.
plus c.
Now, you think you're done, you're not quite. Because you gotta remember your
Never
rules of
done.
logarithms. Those can be lumped together.
They can't.
You multiply.
Be x cubed plus 3x. Now, how can we lump these together into a single log?
ln of X.
Will it be positive? Yes, because this just means I'm gonna kick that one downstairs. Now watch, there's a whole bunch gonna happen right here, so watch for it. It's gonna be plus the natural log of, and yeah, there's a reason I don't have this, and you'll see in just a minute, because I'm anticipating something.
X plus 1 over.
X minus 1, that's the
Minus
positive one,
X plus.
over x plus 1
Squared.
squared.
Why is it squared? Because
Because
two of them.
both of them have a coefficient of 2 out front, which
2.
makes both of them have a power of 2 on them.
Plus c.
Plus c.
That's a lot of stuff.
And the reason why I didn't put absolutes on this is because I was anticipating this. Anything that you square is positive. Except you can't let x equal.
Negative 1. Negative.
You also can't let x equal 1. Because you can't log 0.
You can't.
No.
So we will say x must be greater than 1.
Has to be greater than 1. You can't log negative either.
Can't log negatives or 0.
Wait, can't you log 1 though?
Yeah. But if x was exactly 1, then 1 minus 1 would be 0 in the numerator. You'd be logging 0.
So you can say X.
So any number greater than 1 is going to work.
Well, what if X was 0.1?
Then it's negative. You can't log it.
You can
Yeah,
log
then this would be negative. You'd have 0.9, and you'd have negative 0.9 over 1.1 squared. That's true, that's true. So, you're right. Where else does it go?
Does it
So
apply-
just, you just can't have it at
This
0.
x can't be,
Has to be greater
greater
than
than
0 and not equal to 1.
Not equal to 1.
what has to be greater than 0?
X. Oh, no, it can be 0, it can be less than 0, because.
Yeah, but it can't be less than 1, negative 1.
Yeah, wait, what's the square? It just can't be negative. Where did the square come from?
The 2.
The 2.
These twos.
So why can't we just leave the 2's
Now,
out?
when does the
In front of the log?
Yeah,
That'd be okay, then you need absolutes on these, and you still have to come up with the restrictions on x.
X just can't equal 1 or 0, that's it. No, it could
One
equal
is negative 1.
1 or negative 1?
1 or negative 1, yeah.
Because whatever we get, when we don't get 0 here or 0 here, if we don't get 0 in either one of these places, we'll be squaring something, making it positive, we can log it.
Yeah.
Okay, I'll buy that. Turns out
So
you
we
don't
square
actually have to
before we
find
log
those
it.
restrictions, but it's always
Yeah,
important
does
to
the square
consider.
come before the log?
Huh?
Does the square come before the log?
we solve for inside, do we square then log or log then square?
You square then log. It's an exponent on the thing you're logging, not an exponent on the log. Well, look, she's gotta go throw up, she's so upset about it.
Her birthday. And she's 15.
Sucky birthday.
Notice that they got what we got, that they left the 2 out front and absolute values their log. I don't care, as long as it's correct. And they didn't find any restrictions on x, and I think that's an important thing to always consider. It's because the focus was on the skill, not all the little leavings on the outside. But I think it's always an important thing to consider.
They left out the x cubed plus 3x. Wait, oh, I'm looking at the wrong one, never mind. Sorry.
All right, we're gonna try example 3. When we get done with example 3, we're gonna have a little bit, teeny tiny bit of a little discussion, and then I'll be done. So there's 3 examples here, and you get to practice this in the decomposition and also using it to integrate before we get done. Before the end of today. Then I expect you to practice this overnight so that it doesn't become an issue of understanding what's going on when we actually use it for logistic regression. I mean, not regressions, logistic things, scenarios.
I actually just used it.
Okay, this example 3 has got 3 partial fraction decomposition pieces. So, could someone read that for me? By the way, they didn't offer this as an integral. They're offering it as a differential equation, which means you're going to integrate. So it's going to be dy dx equals
6x squared minus 8x minus 4 over x squared minus 4.
that's a 4. I thought it was a 1. Okay, 4.
4 times x minus 1.
Okay. Do you anticipate having to FOIL these out and do long division first?
No.
No, because this will be squared, and if you FOIL this out, this would be cubed. And as long as this is less than this, we're good to use the partial fraction, ready to go.
Yes.
See what I'm saying?
Say that again.
As long as the degree of the numerator is less than the degree of the denominator, we're good to go on partial fraction decomposition. So there is no long division required because the degree of the denominator is x cubed.
Okay.
Do you see?
If the base is big,
Where
good
is
to go.
Oh, yeah, got it.
You with me there?
Yeah.
So we don't need to do the long division on this.
Okay.
All right.
We just have to factor.
What we have to do is continue factoring this if possible, and it is. So it's going to be x minus 2, x plus 2, and then I'll just bring the x minus 1 so they're all down. We can see all 3 of them together in one line. Is that okay?
Yep.
So the partial fraction decomposition associated with this is going to be a over x minus 2 plus b over x plus 2 plus c over x minus 1. Every linear factor in the denominator gets his own constant term. We good? All right, so we're going to multiply through by the common denominator next. That's the next task. And so I'm going to get over here, I'm going to get 6x squared minus 8x minus 4 equals, because they all cancel there. Here, only one is going to cancel. So I'm going to have a times x plus 2 times x minus 1. It'll be easier when we let something happen if you leave it this form. You can FOIL it out if you want, but I don't want to. Plus b times x minus 2, x minus 1, plus c times, if it's okay with you, I'm going to write, well, no, I'll leave it. I'll leave it at x minus 2, x plus 2.
So.
Everybody understand that little piece right there? It wasn't too bad?
Yep.
Now, what do you want to let x equal?
To cancel out these.
Well, that cancels out the A.
Let x equal 2. What will this be?
24 minus 16 minus 4. Minus 4.
4.
I agree, 4. This will be, this one right here will be 24 minus 16, which is 8, minus 4, which is 4. Yeah?
Yeah.
Equals. Okay, if I let x equal 2, I'm going to have a times 4 times 1. You agree?
Yeah.
These have both got an x minus 2 in them, and they both go. That's a happy thing. So, so that I got more space here, that means that, so I'm going to go right instead of down, which I'm supposed to do, but I don't have space. So, a is 1.
Don't we have to do the rest of that?
No, because if x is 2, this one goes to 0, and so does that.
And then those both go to 0.
Oh.
Which is a happy thing, because every one of these factors is used twice. So 2 of them will fall out every time. That's nice. Okay, what do you want to let happen next? And if I let x be negative 2, I'm going to get 24 plus 16, which is 40, minus 4. So we're going to get 36 equals. This will fall out. This will fall out, and I end up with b, do the arithmetic, times negative 4. Negative 4 here, and negative 3 there. Negative 4 times negative 3 is 12. So b is, yep, all that for 3. Okay? Let, what's next? X equal, let x equal 1. If I let x equal 1, what will I have here? -6 is what I got. I don't know that's right, but this one will go out, this one will go out, I'm left with that one. And so it's going to be 1 minus 2, which is -1, and 1 plus 2, which is 3, so I have -3c. Is that right? Everybody do the arithmetic? If you let x equal 1 on that end thing, I'm gonna get -1 times 3. Okay, so -3c.
I was adding in my head.
And so that means that c is 2. Yeah, 1, 3, 2. So what we're really trying to integrate is this side now that we know what a, b, and c is. So if I put the integral together at the same time I make these substitutions, it will be the integral. Oh, by the way, if I integrate this side with, dy dx is the derivative of y if there's an x in it, right? And that's all there is x is in there. So the antiderivative of this is just y. The antiderivative of this with respect to x is what I'm doing now. Y will be equal to the derivative of a, which is 1 over x minus 2. The next one is positive, it's positive, and b, and so it's 3 times the integral of 1 over x plus 2. Minus, because c is still sorry, plus, and it'll be 2 times the integral of 1 over x minus 1 dx. And notice that all of these are 1s over a linear term, which means every one of the integrals is going to be a logarithm. What?
Is it possible to get a function that can be decomposed?
Oh, yeah.
Oh, really?
Yeah, these will be contrived to work.
Sorry, what?
But there's a lot of not a lot. There are a few situations where there's no other way to get at this than this. So let's just get the other one, okay? So the result is what? Y equals the natural log of, don't forget your absolute values, x minus 2, then
Plus 3. There's 2 right on there.
doesn't this kind of look like when you practiced in pre-calc and algebra 2 when you had a bunch of logs all strung out and they make you condense them?
I don't remember how to do that, but.
Okay, well, we may need to study up on that too. This one's positive, this one's positive, this one's positive. There are no denominators here, so it is the natural log of x minus 2
Parentheses.
times x plus 2 times x minus 1.
Cubed and squared. Plus cubed and squared for the x plus 2.
Oh, yeah. Where are they?
X
Cubed
plus
here?
2 is
Squared here, yeah.
Wow. Interesting.
Okay? Do you understand the process? You may have to have somebody help you, maybe me, remember how to take a bunch of logs and condense them if you can't remember the rules for them. Okay? Boy, I hope you could see all of that. I missed a little bit, maybe. There you go. Okay. So that's all I want you to do in today's practice. You will have to do some integrating in the process, but that's a good thing to practice.
That's cool.
All right, so what I want you to do, you have the assignment on your paper, but I want you to do any of the exercises from 1 to 22. Those will be these partial fractions you can do. Anything from 23 on, don't do them until I get you prepared for it. Okay? So any of the exercises assigned from 1 to 22, people watching this, that's what you gotta do. See ya, have fun, bye.
Alright, let's go back to chat. Actually, let's probably